In this video, we're going to look at the run plot comparison module of Catalight. And I'm going to show you how you can not only run analysis on data you've collected per experiment in Catalight, but you can also make comparisons between these different experiments using this handy UI-based Python module. So in a previous video, I showed you how to use the run initial analysis module. And we can see if we go into this example data set that's included in the Catalight GitHub repository. If we go into one of our demo samples and experiments and look in the results folder, now we see that we have output all this data. We have these three different plots showing kind of what happened in our experiments as a function of the GC sample, or as we change different conditions in the experiment. And then we also have these three data files that show us the average concentration for different experimental conditions, and then the concentrations of every single one of those ASCII files that we generated. And this is great data to have. It's especially good to put into PowerPoint, for example, and compare between different experiments and see kind of what happened in this different experimental study that you ran. But most often what we really want to do is make comparisons either between two different experiments or two different samples. So we might want to compare between what happened in our temperature sweep and our power sweep, or we might want to make some comparisons between sample 1 and sample 2, or however many samples that you might have. So within Catalight, there's a tool to make this easier. So just like in the run initial analysis demo, this run plot comparison is a module that you can access in a number of different ways. You can access it through command line by just running this module as a script. You can access it through scripting by writing some code like you see down here at the bottom for yourself, or using scripting to put in these different inputs directly into the main function. Or you can just open this file in an IDE and you can just hit run on the file, and it'll run directly for you. So that's the way that we're going to do it here, just like in the previous video. And this is going to open us right up into our repository. We'll go up 2 levels from this, and we'll find our example data folder. So remember, this data I've already run the initial analysis on. This code won't work if you don't have the initial analysis. And here we're also using the non-native file dialog through Qt. That gives us this cool option to be able to select multiple different experiment folders at once. So I'll select both of these 2 samples and hit choose. And now what's different from the initial analysis is that we're opening up what I call the data extractor window. So the data extractor is meant to help us select multiple different data types, data sets, and put custom labels on those for how we want to see them get plotted out. So here we have this widget that folds up and down these different experiments. And what the data extractor does by its default behavior is it's going to go through all the different subfolders of whatever folders you pass to it. So whatever we selected on the previous window, and it's going to look for anything that has an average concentration CSV file. So it's a little bit arbitrary that it looks for that file in particular, but what it's really doing is it's looking to see if you've run the initial analysis on your sample already, because it wants you to run the initial analysis first before you try to make any plot comparisons. So any folder that has analyzed data inside of it, it's going to display that folder name here. And then you can use these checkboxes to select any number of these different experiment folders that you want. So here, we're going to check the 2 temperature sweeps for our 2 different samples. And then over here on the right, you can enter in a data label. And this data label is going to be exactly what shows up inside of the legend whenever these plots get generated. So we'll just call sample 1 and sample 2 for now, and then we'll hit OK. And then that opens up another UI that should look pretty similar to one you saw in the previous initial analysis video, But now there's a couple fewer plotting options because this function takes fewer inputs, so you don't need to put in as many arguments. And then I'll show you in a second that at the bottom, there's these two new inputs. So again, we'll put in our reactant and our target molecule and make sure that these names match exactly with what is in the calibration file. And then for the figure size, for this one, I'm going to go a little bit bigger and make a little bit bigger of a figure. And then we have these two options here that are new to plot either conversion and selectivity plots, two different plots, where in each of these plots, the x-axis is going to be whatever your independent variable is. So it's important if you're going to select this as your option, that you need to make sure that whatever you're trying to plot has the same independent variable. So here we're running two temperature sweeps, so it's okay for us to select this option. And then the second option we'll show you in a minute is going to plot selectivity versus conversion. So that's going to be 2% units for your two axes. And you can do comparisons between different types of experiments using that plot. So we'll go ahead and we'll plot this one out first. We hit OK. And that produces these two separate plots. That's plotting conversion in one plot as a function of the independent variable, and then selectivity on the other plot as a function of the independent variable. And then you can see these experiments weren't run over the exact same range, but still we can plot both of these two experiments for comparisons between these two different samples. So you can save this data using the matplotlib kind of functionality. Save it as whatever type you want. And here we'll just close out of these two windows. And then we'll also close out of this terminal that opened up. And I'm going to rerun this script. And we'll look at how the other type of plot is done. So we'll go up to directories again and go to example data. And this time I'll go up one. And I'm going to hit example data to show you how that'll work. So we'll hit choose on that. And now you can see that our root directory that we start in is different. Now we're in the Catalight repository, but we have access to all the same data that we did before. So this tool went in and it looked for every subfolder that contained data, and it's pulling out automatically where the experiment names are. So we'll go ahead and here we'll select a couple of different data types so that we can do a comparison between things that don't have the same independent axis. And we'll name them something. Sample 1 power. And I forgot the 1 here. And then down here, we'll do sample 2 power and sample 2 temp. Okay. And so now we can hit OK on this dialog. It'll bring up the same window. So if this is getting to be annoying to you, you're running the same analysis again and again, remember, you don't have to use this UI to be able to access these different files. You can 100% just come into the script or even make your own script, preferably, where you're just calling this main function. And here, if you go into the documentation or if you go onto the read the docs page, you can see what all these different parameters mean. And a lot of these parameters even have their own defaults. So here you have to enter in something specific for most of these, but you can script this to repeat itself over different files, given different data labels, as much as you want, without having to use the UI every time if that's becoming a bit cumbersome. But the UI is a nice tool to have, especially so you don't have to write any code if you don't want to or if you don't know how. So here we'll select this other option, plot selectivity versus conversion, and then we'll hit OK on that. And that'll generate a single plot for us. And now you can see that we have all these different data types that are plotted on the same set of axes, even though they're completely different experiments. And here you can see that we also can generate our error bars in both X and Y. And in particular, what happens frequently is these low conversion data points have bigger error than you might expect. So I know in the example data cases, there's actually some inconsistent runs in two of these data points. And so this doesn't seem to be artificial error, even though it is quite large. But low conversion experiments are particularly sensitive to have higher error in the way that our error calculations are being done. So keep an eye out for that. But it could be a good indication that there's something not quite in steady state in your experiment that you're seeing these big errors. And we've got some other tools that you can use to go and look at those individual chromatograms, like our chromatogram scanner GUI, if you want to take a look at what else is happening. And so last note for this video is you'll notice that in all of these graphs that get output, it's just the Matplotlib standard format for everything. I mean, we've put in a little bit of thicker borders, and there's a couple of size changes that happen with the font. But for the most part, these are pretty stock files that get output. So what you can do is either save these as a SVG type, and you can go ahead and edit it in some vector graphics editor software, some vector graphics editing software like Inkscape, or Illustrator, or you can interact with these figures programmatically by getting these different returns from the GUI or from the, again, scripted inputs, if you call this main function. And then you can use the Matplotlib toolbox to edit these graphs in whatever way you want. So we leave them pretty stock just because we assume that, you know, all of the different users are going to want to interact with this in their own way.